All right. Well, good morning to anyone watching this live or after the fact. This is another one of our GRE office hours where students who are taking my courses and anyone else can just hop in and bring some questions. So we have one student with us today, S. And S, I don't know if you sent me these questions here. If you have any questions, S, feel free to send them over. Um, and we'll work through them. And while S does that, in case anyone is unfamiliar with the channel, this is the GRE channel. I do all things related to the GRE. If you are interested in taking the GRE course, I have one starting next weekend. That's Saturday, November 16th at 10 a.m. Pacific. So you're welcome to join us. And as I always like to offer, you're welcome to sit in on the first session free of charge. So just to get a sense of what the course is like and if it's the right cup of tea for you. Um, Otherwise, I also have a video version of the course, which covers everything that's in the live course, everything that's in the live Zoom course, but just in video format. Of course, the downside to that is that you won't be able to, ask questions about problems. But if you're, a self starter, self motivated, that's an option for you. I'll say to anyone who is thinking about the GRE at all, the first thing that I would recommend doing is getting the official books. That's the official guide to the GRE from ETS and the two practice books for verbal and quant. Those books are it. Like those come from the test maker. And, Kaplan, Princeton, Magoosh, they're all great imitations of the real thing, but you really want to study with the real thing. You can't beat the real thing. Because sometimes I start working with people and they say, "Oh, I've been working with the Kaplan book for 6 months." That's not a complete loss, but it's like what's that called in music? Like it's like a tribute band, right? It's not like the real thing. When you're on Spotify and you like listen to a song, you're like, wait, this isn't the band. That's what it's like. Anyway, um, so official guide from the GRE ETS. And as a supplement, if I'm gonna pick a favorite supplement, I would say my favorite supplement is Manhattan, the Manhattan 5 pound book of practice, because it really allows you to dive into one particular content area. So if you need to work on exponents, there's a whole chapter on exponents that you can do. Sorry. And S, just making sure that you're sending those questions over. And once we have those, we can get going. Um, Otherwise, lots of deadlines coming up for MBA programs. I'd say most of my students are on the MBA kind of track. I also work with students who are applying to PA school, PT school, CRNA, petroleum engineering. I've worked with people in all sorts of fields. Um, but be aware of those deadlines. And if you have bigger questions about admissions, because my expertise is really the test. I just focus on this test. But if you have bigger questions about admissions, you can check out some of the videos that I've done recently. I've interviewed these admissions advisors. So a couple weeks ago, I emailed a guy named Eric Lucrezia. Really, really interesting guy. He has a company called Candidate Coach. And then the following week, I emailed Mary Pat Jacobs, who runs Apply Point. Um, she has I would say, a real specialty in MBA kind of stuff. That's her niche. And then yesterday, I had a great conversation with this guy named Chuky, Chuky. Um, and he has a company called Sojourning Scholar, which is focused on helping international students who are coming to the United States to study for grad school. So if you're an international student, and I do have quite a few of them, a good chunk of my audience, and I can tell this by YouTube analytics, a good chunk of my audience comes from outside the United States. Chuki is great. He can help you figure out like a plan for scholarships and funding and knows all about like the visa stuff, which is something that I was completely unaware of. So all of those conversations are on my YouTube page, and you can find them. Um, you can find them on my YouTube page. All right, so let's take a look at some of these questions. So S just sent over our first question of the day here. And I'm going to share the screen so that we can all see it. Boom. All right. So the average arithmetic mean, those two words mean the same thing, by the way. If the average of the 11 numbers is 14, the average of 9 numbers in the list is 9. What is the average of the other 2 numbers? So there are 11 numbers in this list. I could, if I wanted to, do this. I'm not actually going to do that all the time, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Excuse me. So anytime I see the word average or mean, I have this sort of like knee-jerk reaction where I write S over N equals A. And what that stands for is the sum of the numbers divided by the number of numbers is equal to the average. I'm guessing that people kind of intuitively know this definition, even if they don't know it in this formula. But I like the formula. It's a nice, easy way to get going. So the average of all of these numbers, the sum of these 11 numbers, I don't know, divided by the number of numbers, I know there are 11 numbers, is equal to the average of 14. Well, this will allow me to find the average. Excuse me, find the sum, the missing S there. So I'm going to multiply this 11 times 14 to cancel that out, right? Chop, chop, and chop, chop. And so what I get is that the sum of these 11 numbers is 14 times 11, which is 154. There we go. So the sum of those 11 numbers is 154. And then they say, oh, wait, but hold on. The sum of just 9 of these numbers, so I'll kind of highlight 9 of these, just these numbers, these two are out of the club, right, is 9. So I'll draw a line here. And I could say that the sum of these 9 numbers divided by the number of numbers, which is 9, is equal to 9. So that means that the sum of these 9 numbers is equal to 81. Okay. The question is, what's the average of these 2 missing numbers? Let's call them, I don't want to use variables. We'll call them circle and square, right? I want to know the sum of these 2 numbers, excuse me, the average of these 2 numbers. And to find the average of 2 numbers, I add them together and divide it by 2. But I don't know what those 2 numbers are. Well, let's look at the sums we have. I know that the sum of these numbers right here, these first 9 numbers, is 81. I know the sum of all of these numbers, all 11 numbers, is 154. Well, what's the gap, right, between this and this? What did we lose when we went from 154 to 81? Well, it looks like we lost 73, right? So that means that the sum of these 2 numbers is 73. Circle plus square is 73. And so the average of circle plus square is 73 divided by 2, or 36.5. Is that all good, S? Does that make sense?
Yes, definitely.
Excellent. All right. Let's go to the next one here. So this one is coordinate geometry. And I would put, by the way, for anyone watching, I would put coordinate geometry up there as like one of the prime topics to know. It kind of overlaps in terms of like it's difficult and it comes up relatively frequently. Um, what makes coordinate geometry a little tough is that it's kind of a union between algebra and geometry. It's coordinate geometry, so you know there's some geometry involved, but there's also some algebra. Okay, so which of the following points are on the graphs of both the equation y equals x plus 2 and the equation y equals x squared in the xy plane? So a very, very straightforward way to do this. Let me talk about what it means for a point to be on the graph of something. And like let's take this. Y equals x plus 2. For any equation that you have, you could create an xy table, right? To sort of like test numbers. And you could ask yourself, okay, what happens when x is equal to 1? Well, when x equals 1, 1 plus 2, y equals 3. The point, and I'll put this in parentheses here, the point 1, 3, I can now say is on the line or on the graph. That's the idea, is that if if a pair of xy points, if an x and a y make this equation true, we're describing an xy point that is on the graph. I'll do another one. When I plug in 2, right? 2, x is 2, plus 2, so y is 4. That means that the point 2, 4 is on the graph. So for this question, they don't just want it to be on this graph, they want it to be on both of them. So we're going to run through these numbers, plug them into both equations, and whichever ones satisfy both equations, we know are going to be on both graphs. So I'll put y equals x plus 2 over there and y equals x squared over there. All right, well, let's start with this one. Here, the x is negative 2 and the y is 0. So let's plug it in. Negative 2 for x and 0 for y. 0 equals negative 2 plus 2. Is that a true statement? It is. So it satisfies this one. But if I plug it in over here, y is 0, x is negative 2. 0 does not equal negative 2 squared, right? So that's out. This one does not satisfy both. Has to satisfy both equations. Okay, so moving on. Let me erase this. Boom. The next one that we're doing is negative 1, 1. So let's plug in 1 for y and negative 1 for x. 1 equals negative 1 plus 2. So 1 equals 1. Yeah, that works. How about over here? Does 1 equal negative 1 squared? It sure does. So that one is in. How about the next one? 0, 2. X is 0, y is 2. Let's see if it works. 2 equals 0 plus 2. Yeah, this one seems to work for everyone, right? And 2 equals 0 squared. Oh, I don't think so. 2 does not equal 0 squared. So that's out. Boom. Okay, 1, 1. 1 equals 1 plus 2. Well, that doesn't work. So that's out. And finally, 2 and 4. I know it works for here because we tested this a minute ago. We'll make x equal to 2, y equal to 4. So 4 equals 2 plus 2. So 4 equals 4. Check here. And then, sorry, y is 4. So 4 equals 2 squared. Last I checked, that was true. So those are the correct answers here. Now, for anyone watching who, I don't know, is a little curious about a more algebraic way to do it, and I'm not at all saying that this way wasn't valid, but it took a little time. We had to test all of them. If anyone is into the algebra and wants to see it, very quickly, I'll say this. Remember that we're talking about lines in a coordinate plane here, right? So I could even graph this. One line is y equals x plus 2. So slope of 1, a y-intercept of 2. So it looks like that. That's not a bad line. And then the other one is y equals x squared. So it's a parabola uh, starting here. So it's going to look like that. Now, again, you don't need this level of algebra for the test, but I'll just point out this is a linear function, this is a quadratic function, this is a line, and this is a parabola. It's only possible for these to cross twice, a maximum of two times, right? And sure enough, it's there and there. So if you really wanted to be fancy, what you could do is set these two y's equal to each other and say, okay, x plus 2 equals x squared. I want to know where x plus 2 equals x squared. And then from there, I can rearrange this to x squared minus x minus 2 equals 0. Factor this into x minus 2x plus 1 equals 0. And so I know that the two values of x where these two are equal are going to be x equals 2 and x equals 1. Excuse me, negative 1. And sure enough, that's that. But again, I would, even for myself, like I only noticed this as I was going through it. I was like, oh, I could do it that way. Even for myself, I would just plug it in, frankly. All right, let's go to the next one. Let's see here. There's another one, right? Yep. All right. So, quantitative comparison, everyone's favorite kind of question. And I say that non-sarcastically. I think quantitative comparison should be everyone's favorite kind of question because it's so, you can't solve all of them, but you can get a lot of them down to a 50-50. Let me give you an example right here. So we have this triangle, and I'm gonna write this in all caps. Figures are not drawn to scale. What's that saying? Don't believe your lion eyes. Figures are not drawn to scale. So on multiple choice questions, A, B, C, D, E, usually they are drawn to scale. On quantitative comparison questions like this one that we're doing right now, this is a quant comparison, right? Quantity A, quantity B, they are almost certainly not drawn to scale. So if we look at this, let me just see this here. We have RS equals ST, right? That's something that we know to be true. So RS equals ST. We know it's a triangle, right? Because it calls it a triangle, but we don't know anything else. And to prove my point, what I'll kind of emphasize is it could be like here, here, and here. It could be here, here, and here. Like this, you could draw this in so many different ways. In other words, it's not necessarily slanted in that exact direction. So where do I start with this one? Well, I'm going to start with a case that's kind of easy to see. I'm going to make this a perfect isosceles triangle. I'll redraw it right here. RSTU. And I know some people may be looking at this and saying like, well, how can you just like bend it like that? There's nothing in the description that tells me like what this angle measure is and what this angle measure is and how long these lines are. Nothing says that. All I know is that it's a triangle, that these two lines are equal. And so S is, you could say S is the midpoint, but that's it. I can draw any triangle I want. And so I'm going to draw this one as a starter. And in this triangle that I've drawn, these two sides are equal to each other, right? I've drawn it such that they are equal to each other. They have the same base, both triangles, RUS and SUT, and they have the same height. So these two triangles are equal to each other in at least one case. So maybe that's as far as I can get, but check this out. If I know that the two triangles are equal to each other, well, I know that quantity A isn't bigger, and I know that quantity B isn't bigger. So what I'm going to do now is try to find a different version of this triangle or of these triangles where they aren't equal to each other. And if I can find that, then the answer is D. But if I keep finding that they're equal to each other, then the answer has to be C. Okay, well, check this. So let's look at these two triangles. Let's start with RUS. RUS. That's the base, and I'm going to draw the height of this triangle, right? That's the height of triangle RUS. So let's call that height. Now, the base of triangle ST is the same because I know that these two are equal. It told me that these are equal. So the base is the same. What's the height of triangle SUT in this shape that I've drawn? Well, if that's the base, that is the height, the same height. These triangles share the same bases, share the same heights, and therefore they are equal. So quantity C is a correct answer here. Okay, 1 second. Let me just clean up my desktop here. Got a lot of windows floating around. And let's see the next one here. So that's we did that one. We did that one. Let's do this one. All right. So for this one, we have, I'll share it. For this one, the diameter of circle C is 3 times the diameter of circle D. Or if the diameter of circle C is 3 times the diameter of circle D, then the area of circle C is how many times the area of circle D. The first thing that I'll note about this, and the first thing to like always pay attention to, is the fact that they don't give us any values, right? They don't give us any hard and fast values on this one. It's just it's like scale. It says this one is 3 times bigger than that. And what I'm getting at is whatever the answer here, and I think this one is numeric entry, right? You have to write your own answer. Whatever the answer here, sorry, 1 second. Whatever the answer here, it's going to be true no matter how big or small the circle. So we could be talking about circles like this big. We could be talking about huge circles. So for our sake, let's just make up a value. If you don't like the word make up, I'm going to say test a value. So let's say that the diameter of circle C is 9. Right? So the diameter of circle C is 9. And that diameter is 3 times the diameter of circle D. So we'll make the diameter of circle D 3. Right? So this is circle C. This is circle D. We want to know the area of circle C. Sorry. We want to know how many times greater the area of circle C is compared to circle D. Well, let's find it. So the area of circle C is going to be, as a review, area equals pi r squared, right? So the radius is 4.5. So the radius squared, I'm a little rusty on my squares here, but 4.5, oops, 4.5 times 4.5 is equal to 20.25. That is my area, 20.25 pi, because the radius is r. R squared times pi is 20.25 pi. There we go. And then over here, If the diameter is 3, the radius is 1.5. So what I get there is 1.5 squared times pi, and that's 2.25 pi. So the question is, how many times bigger is the big one compared to the small one? Well, let's find out. 20.25 divided by 2.25 gives me 9. So circle C is 9 times greater than circle D. Oops. Come on. Where did that go? Um, and we have Mohammed join us here. Hey, Mohammed, just as a heads up, we're streaming right now live. So if you want to change your name or whatever, feel free to do that. Sarah has sent a few questions. I think I mentioned this in the description of the sign up, Mohammed. The office hour, I kind of give priority to students who are enrolled in a course, and then kind of like goes down the line from there. So once we get through Sarah's questions, we can cover any questions that you have. Feel free to send those in preparation. Again, no promise that I will get to them though. Okay, so we just did that one. Let's pull this one up. Oh, this is a great question. I'm keeping everyone in suspense. They're like, what question is it? I can't wait. All right. So the quantities S and T are positive and related by the equation S equals K over T, where K is a constant. If the value of S increases by 50%, then the value of T, decreases by what percent? All right. Again, I'll point out here, they do not give us exact values. And inherently, what that means is that this should be true no matter what values we work with, right? It should be true if we set something equal to 100 or 500 or whatever. Now, the one constraint that we do have, I should say two constraints, is this. S has to equal K over T. So whatever we pick for S, K, and T, they have to fit in that equation. And K is a constant. That's very important. And I know that we tend to like brush by that sometimes when they say K is a constant. You're like, okay, all right, it's some number, but it matters here, and I'll get to that. So let's start by making up some numbers. I'm going to say that S equals 50, K equals 100, and T equals 2. Now, I didn't just pull those numbers out of thin air, right? I made sure that they fit into this. And obviously, I've done this problem a million times, so I'm like familiar with the ins and outs of it, but it may take you a second to like, trial and error and see what actually works. So I'll give everyone a minute to kind of process that and make sure, yeah, the S 50 is equal to 100 divided by 2. All right, so what's next? K is a constant. What that means, literally, the word constant, is that it does not change. It is fixed. So what we're about to do is change S and T, but K has to stay the same. That's the crux of this question. The value of S increases by 50%. Well, let's look at S. S started as 50. We're going to increase that by 50%. And you can use your calculator to do this. When I increase S by 50%, I get 75. We want to know what happens to the value of T. Well, remember, K is constant, so K stays at 100. What they're basically asking is, what does this last one have to be so that this equation still holds true? Well, let me plug in what I have so far. S is 75. 75 equals 100 over T, right? I'm looking for this value. And so I'm going to solve for it. I do 100 divided by 75. Let's see here. Let me just make sure I have that. There we go. 100 divided by 75 is 1.33333. Repeating. So T went from being 2 to 1.33333 repeating. And we want to know what kind of a discount that was, what percent discount that was. Well, however you do percent discounts, you can do it that way. I'll just use the new minus old over old formula times 100, right? The new value is 1.333. The old value is 2. And when I do this, I found that it decreased 66%. Excuse me. I'm sorry. I totally had that wrong. Not 66%. A third, right? And I'll write the numbers out here. So new minus old over old, 1.3333 minus 2 over 2 gives me 0.33333 or negative 0.333, which is 33%. It's a 33% decrease. All right. Next up, that was it on S's questions. Abdul, if you have questions, you're welcome to send them over by email or ask them out loud if you're comfortable sharing your voice on the internet. Um, Likewise, S, if there are any other ones, I'll give everyone a minute or two to send any. But if not, that's totally fine. Um, and Abdul, I think you and I were supposed to check in the other day. If you want to stick around afterward, we can talk one on one. But
Yeah,
just
looking
yeah,
forward to it, Andrew.
great.
Yeah.
Um, Let me just see. So S or Abdul, are there any other individual problems that you want to take a look at?
Uh, Not related to problem, but yeah, to the I want to ask some like strategy or the
Mhm.
preparation questions that we can
Sure.
have it on, right?
Yeah. 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 And you're welcome to ask those now while we're streaming this live or when we check in afterward, whatever you'd prefer.
Acha, it's I can ask now, right?
Yeah. Yeah. Absolutely.
Okay, so let me say you my case. My exam is in like 8 days from now.
Mhm.
My GRE schedule 8 days from now, and I have done like arithmetic and algebra for a
Mhm.
like decently. Now I'm doing coordinate geometry and all the foundation stuff, and I'm also solving some basic questions uh, related to it, right? So
Mhm.
now I miss solving Manhattan 5LB. So I want you like to suggest me whether I should for at this point I should try to solve 5LB book, or should I only focus on official materials, or if you know KMF material.
Yeah.
I saw some good reviews on KMF that the problems are being reflected in the exams directly from there. I don't know, but yeah, you can just clarify.
Sure. So for mixed practice, I would say stick to official material. Um, if you want targeted practice, I'll kind of describe like the process. You want to do a mixed practice set from the official books, right? Um, um, Based on that, you might find like, oh, I need work on coordinate geometry or whatever. That's when you go to the Manhattan book. So I would say the Manhattan book is best for drilling a particular skill. Mixed practice is good for experiencing what the test will be like. I have heard of the KMF stuff. I'm not super familiar with it. Um, it is the like the Chinese site, right?
Yep, yep.
Yeah. I've seen some of them, not super familiar with them, not sure where they get their questions from or if they're legit, but I have seen those. Yeah.
So what are your views on it? Like at this point of time, at last moment, is it worth like looking at it, or just doing official guide and focusing on fundamental things would be good for me?
I would say you can't go wrong with the official guide. Like the official guide is uh, from the test maker. So I would put most of your effort there.
All right.
Yeah. Um,
And another
oh yeah.
doubt was regarding the mock test thing. So as I have 8 days remaining, so some suggest that you write a daily one mock test in the last week. So
Mhm.
what are your views upon it?
Sure. So I would say uh, you do as many mock tests as you can, but make sure that you're not just taking them and moving on to the next one. It's really important to take the test, review the answers you got wrong in a very, very methodical way, and and go from there. I would say for every test you take, you should probably spend at least about an hour to 2 hours just reviewing the test. So if you have time to take a test every single day, sure, but make sure that you're not just taking the test, but taking the test and reviewing it afterward.
All right.
Yeah. Um, okay, so S sent another question here. Let me share this. Um, Ray is 2 centimeters taller than Lynn, and Ray is 3 centimeters taller than Sam. The average height of Ray, Lynn, and Sam, the median height of Ray, Lynn, and Sam. Again, on this one, I would just point out my favorite thing to point out is that we don't know how tall Ray is. So let's test something. I know people get like a little antsy when I say let's make up a number, but let's test. I'm not saying it's this, but let's see what happens when Ray is let's say Ray is 10 centimeters tall. That's pretty sure. I'm in the I use the American system. So 10 centimeters is like a very, very tiny person. So Ray's 10 centimeters tall. He's 2 centimeters taller than Lynn. So we can say now that Lynn is 8 centimeters tall. And we can say that Ray is 3 centimeters taller than Sam. So Sam is 7. We want to know what's greater. The average height of Ray, Lynn, and Sam. So the average height of this. And if I add this together, that's 7 plus 8, 15 plus 10, 25 over 3. 25 over 3. And the median height of Ray, Lynn, and Sam. Well, Lynn is the median, right? So it's 24 over 3. 8. Lynn is the median height. And of course, I could I could do this with decimals if these fractions get confusing and just say this is like 8 point something. 8.333, is that right? And this is 8. So this one's taller in this one case. Wait, did I do that right? Yeah. Because we said 2 centimeters taller than Lynn, 3 centimeters taller than Sam. So average is 8.3333. The median is 8. So that means that answer options B and C are out. We could also now start to think about why the average will always be greater. And we can use one of my favorite little diagrams, and that's the game of tug of war. Lynn is the middle value, right? Lynn will always be the median. But the question is who's pulling harder from each side if we're talking about like an average? Well, Sam's down here and Ray is up here. Ray is 2 centimeters taller than Lynn, and Sam is 1 centimeter shorter. So the average is always going to be a little pulled up toward Ray, meaning that the average is always going to be greater than the median. So that means that quantity A is greater in this case. Tug of war is one of my favorite little diagrams to draw. All right. Anyone else? Going once? Going twice? All right. Well, I'm going to stop sharing here. Again, if you're watching this after the fact, thank you for tuning in. Um, I'll remind everyone that I have a live course that begins 1 week from today, November 16th. Not from today, from yesterday, 1 week from yesterday, Saturday, November 16th at 10 a.m. Pacific time. It's on Zoom. It's 16 hours total. It's not all in one day. It's spaced out over several weeks. And you can sign up at my website, testprepstudios.com. All right. Thank you very much for tuning in.